So my name is Stephen Lombardo. I'm the founder of a company called Zetetic. We make a product, it's really a project as well, I'll talk a little bit about it, called SQLCipher. And it's one of the tools that you can use to really help secure applications that keep data, specifically user data, locally on their device. So it's really kind of difficult to discuss security in general without having a little bit of an understanding of the threat model. So the threat model is really about what are we actually trying to secure. You know, how sensitive is the data? What are the potential impacts if there's some sort of breach or an attack? You know, what are the different ways that an attack might be mounted? So what are those different vectors? So it's really about, the threat model is really about what we care about as developers when we're trying to secure an application. So this talk is really going to cover two things. One is a little bit about the context of mobile security, so about why it's important, why it's something that you should think about if you're in the process of developing an application, or maybe you have already developed an application that you're distributing and you're interested in that, some of the challenges that you might face. And then second, I really want to provide some very detailed information about SQLCipher. So it's an encryption library for Xamarin and for other platforms that you can use. And at the end of this discussion, I would really like it if you know, everybody here had a pretty good understanding of how SQLCipher works, you know, what it does, what benefits it provides, what it doesn't do, because that's also very important, because with security, it's not really, there's not really a silver bullet. You know, you don't have one particular tool that can do everything for you. So you can make you know, really educated decisions about whether or not it's something that you would want to use, or if there are other things that are more appropriate for your applications. So with that, I think we'll kind of get started. So it's clear that mobile devices present some very unique challenges for security. And I think a lot of, you know, corporate security teams recognize this. Individuals recognize it too. You know, they tend to take care of their phones and keep them protected if they can. But ultimately, you know, your mobile phones and your tablets are small. They're light. They're generally untethered. You know, we don't have them like tied to us or handcuffed onto our wrists. So they're kind of easy targets for things like theft, and especially for loss. You know, the ability to have it fall out of your pocket or otherwise be compromised. So there's really, I think, a lot of physical security aspects to mobile devices that you need to worry about, because you can't really protect it in the same way that you can when you talk about security in a traditional sense, or computer security in a traditional sense, where you might be talking about servers that are in a data center with biometric access, or even workstations that are in your corporate office, or even your laptop at home, where there's really a very high barrier of entry to get physical access to the device. Physical access to mobile devices is really, really easy. And then in addition to that, outside of the physical aspect of security, you've got the challenge that these devices are connected more and more now. So it's not really just about the application running on the device. That's not the only way to get information on to a device and get information off of it. So that connected nature of these devices, the fact that they can interface with external systems, is yet another challenge for security. So first, in terms of like accessing applications, you know, I think a lot of the OS vendors, you know, Google and Apple, they recognize that these are sensitive devices, that they're easy to lose, that they're easy to steal, and so that they provide a set of built-in security features. And I think first we'll really take a quick look at those and understand what some of the default security that you get with the devices right out of the box. So PIN codes, they're really the most popular method of securing devices. So how many people here, just rough quick show of hands, use a PIN code for security? Okay, that's less than I thought, but okay. So the thing about PIN codes is that they really make horrible credentials. So they're short, and they're low entropy, so they have very little randomness, which means that they can be easily brute forced. And even if you don't have an attacker who's sophisticated enough to mount a brute force attack, even if you're dealing with like Snoopy neighbor or, you know, Snoopy coworker, the fact is that they're pretty easily guessed. This diagram up here, which looks probably a little bit interesting, is actually a heat map from a data genetics study on the distribution of PIN codes. And what they found is that out of this this analysis of all these leaked PIN codes that they were able to collect, that about 26% of the PIN codes in use could really be guessed within 20 tries. So that's really how common the most frequently used PIN codes are. And some interesting data points on here. If you see down there in the lower left-hand corner, the way that this heat map is organized is you've got the numbers going vertically and horizontally along the axes. So down in the left-hand corner there are pins that are starting with 0 and 1, especially things that are like month/day/day type pins. And that big vertical stripe, that really bright vertical stripe that runs up the side, that's pin codes that start with the number 19. So you've got a lot of 1999, 1972, et cetera in there. And then the diagonal that you see, which is very bright, is repeated couplings. So 21, 21, 12, 12. And then along that diagonal, you see a bunch of really bright spots, probably the brightest ones on there. And those are the quad numbers, 0, 0, 0, 1, 1, 1, 1. And those are very frequently used. So these weak codes make them really susceptible to both guessing attacks, brute force attacks, and also targeted attacks. If you know who you're going after, if somebody's going after you specifically to get some data, for any reason, if they can find out even a little bit about you, what year you were born in, what year your kids were born in, when is your anniversary, a lot of that stuff is pretty easily researched, especially with the internet now. It makes that kind of attack a lot easier. So the other option, which is kind of new, you've got face recognition. This one's pretty big on Android phones, kind of a neat biometric option, something about yourself. And the idea is you take a picture of yourself with the device, and then when you want to get onto it, you kind of hold it up in front of your face, and there's a little circle on it. You center your face on it, and it looks at you, runs a standard facial recognition algorithm, and determines whether or not you should have access. So it sounds secure, right? I mean, it's biometric, but unfortunately, it is really easy to bypass. Does anybody here use facial recognition on any of their devices? Okay, good. It's crazy easy to bypass. You can really, if you can find a picture of somebody off the internet, off the Xamarin page that had my speaker info, you can just take that picture, and on the default settings for facial recognition on Android, you can just hold the phone up to the picture, and it will let you onto the device. The newer versions of it have something called liveliness check, which essentially involves having to blink for the camera. But that's also really easy to bypass with some photoshopping. If you can color over somebody's eyelids with an internet picture, just go to YouTube and search for facial recognition bypass, and you'll get about 150 hits of people doing neat little demos of how they got around this thing. So, and in addition to that, there's a convenience factor with facial recognition because especially it doesn't work in low light. So they have to provide a fallback, and the fallback is usually a PIN code. So at best, it's as secure as your PIN code is, which we know is weak, and at worst, it's horrible. So that's not very good either. Then you've got pattern locks. These are also big on Android and a bit now on Windows too. And the idea here is really a good one because people are naturally better at remembering visual patterns, especially something that's meaningful to them, than they are random strings of numbers or text or passwords. So this is kind of often pointed out as a feature benefit on Android. There are some limitations with pattern locking in terms of your 3x3 grid only has so many combinations. I forget what it is off the top of my head, but like a little north of 300,000 combinations that you can do without overlapping. And a lot of those are very complicated, so you wouldn't actually use them in practice. But it's better than a PIN code. The real fatal flaw there, and does anybody use pattern lock? Okay. So the fatal flaw with pattern lock is really the fact that you can see smudges on the screen. And there's kind of an interesting paper that was done on smudge attacks and smartphone touchscreens that does a really good analysis of it. And it found that across devices, a large number of devices with different glass types, not only could you generally see exactly what the swipe pattern was if held in the right light, you could generally also see the directionality of the swipe pattern. So as you move your finger across because of your fingerprints, the place that you place, the point where you place the finger you can see which direction it's moving. So you can almost always reproduce the swipe pattern on the first shot if you can get access to a used screen. Even if you wipe it, like a lot of people like wipe it on their jeans and then put it back in their pocket, it doesn't really do away with that that evidence of what your code is. So that's not really good either. And then you've got passwords. So how many people here, just out of curiosity, use either an 8-digit PIN code or an 8-digit or more password on their device to secure it? Okay, so all right, good. So 4 or 5. So passwords are the best. I mean, they give you the greatest level of security, better than all the options combined. There is a downside to those too, though. They're inconvenient. They're really difficult to type on a mobile keyboard, especially if you're dealing with a phone rather than a tablet where you have a fuller keyboard. So really, you tend to get a lot of dictionary word type combinations that don't switch between meta characters because you have to hit that keyboard toggle. And they're also, subject to the standard disclaimers about passwords, which is they're frequently reused. In this diagram that you see up here, Mark Burnett of Zeto.net, he wrote a good book. It's called Perfect Passwords, Selection, Protection, and Authentication. But he really found that, for the general case, about 14% of the passwords in use from the various data dumps that he was able to collect use the top 10 passwords. So if you know those top 10, you can get into about 14% of people's information, and about 40% of them are for the top 100. So you're really not dealing with a lot of entropy there either. So, and then you've got device encryption. So this is pretty big. For Apple, if you have your device set up right, it's good. You get device encryption by default. But how many people here? How many people use Android? Okay, so probably about half. How many people have taken the time or the steps to enable encryption on their phone? Right, that's exactly, okay, 1, good. 2, I count 2. So that's the fatal flaw with encryption. It's very troublesome. It's inconvenient to set up. Not only do you have to have your device fully charged and plugged in, you've got to be ready to leave it there for an hour or more to do the encryption while you're not going to get any phone calls, not going to use it, not going to play Angry Birds. So, that's a problem, and most people just don't do it. It's also buried like 5 levels deep in the setup. So, encryption, you can't really trust that people are using it across the board if you support mobile applications. And then even on your iOS devices or Android devices that use encryption, it's really as strong as the person's passcode. So if they're using a weak passcode, then you have a really limited, security in terms of the actual encryption on the device. So the final difficulty is that by default, all of these things are insecure, though. It would be nice if, PIN codes were mandatory. You had to have some sort of authenticator on your phone, but you don't. So most people can go out, they buy a new device, they bring it home, they set it up. A lot of people never bother setting up a passcode. It's not mandatory. Most people don't bother setting up encryption if they're on a non-iOS device. So it really means that even if even if you have just the requirements around iOS, you can't even trust that people are doing the minimum to secure their devices against attacks like that. And then even if they are set up right, the fact is that these devices are so frequently shared. People share their devices if they're corporate devices or point of sale apps or things like that. They may be shared by 10 different people in a given store. If they're personal devices, they may be shared among the family or with friends. If they're in an office, they might be shared among coworkers. So you really need to assume the worst from an application perspective and treat the device as something that may have a device level security, and that would be great, but you can't guarantee it. You can't trust that it's there. So in addition to just kind of the standard let's get on the device side, there's also a whole host of other threats that we need to worry about. You've got forensic toolkits. A lot of these are really targeted more for law enforcement or governments, but they're still out there and they're still a threat. Companies like Elcomsoft or Celebrate, if you ever want to see some pretty interesting stuff about what law enforcement or really anybody who can buy those toolkits can get off a device, go check out some of their, they often have like online demos and things like that that you can check out. But there's a tremendous amount that they can do, including brute forcing attacks on phones, getting into iCloud, things of that nature. So there's a lot of techniques and toolkits that are out there to specifically target mobile devices. You've got rooting and jailbreaking, which is really good for users, but also opens up a vector for untrusted software. So there was a little while ago there was an app, SwiftKey, that was one of those little keyboard applications that I think an Android developer, as a proof of concept, basically took the APK, hacked it up a little bit, and turned it into a keylogger, and then you could install it if you have a rooted phone. It's basically wares, but if people are trying to get the app for free, it is a vector for bad things to happen. Then you've got OS issues. So just in the last, I think, 3 months, there have been 2 separate pin code bypass attacks on iOS. Both of those, I think, were patched and then released, and then another one happened, and there was another release on it. So you have to worry about that. And if you're dealing with Android, the availability of OS upgrades to deal with any sort of security improvements or security issues is bad. You really can't trust that people on older devices are going to be running anything remotely near a modern operating system. So that's a challenge. Removable storage. If you've got applications that save large files out on SIM card, out on SD cards, those can be removed from the device a lot of times, even without a person knowing about it. Until they go and run that application again. And then you've got your cloud services. So these devices, when they started out, you could kind of think of them as a little lockbox. You're putting information with the app, it's got a pin code on it, and the only way you're really getting it out is if you have some sort of custom interface with your application, or it's a backup, it's plugged in the cable. But that's no longer the case. So our applications, just as we're writing them for natural user interfaces and features, they're sharing data. You've got iCloud, which is taking copies of your documents and pushing them out to Apple servers where they have separate copies of them out of your control. If your apps are using things like Dropbox or Google Drive, those are great interfaces. And I'm not even really talking about the security of Google Drive or drawing into question the security of Dropbox, but can you, with any certainty, say that there are controls on the person's home computer where they also have Dropbox installed that's taking every file that you put into it in your app and putting a copy on their home computer? Do you have any control of that environment at all? Even if they have a fully secured device, there's no way that you can control all those different vectors. So these kinds of connectivity issues really make it more important for an application to be wary of security. So we're really placing a lot of trust in this technology that's inherently very difficult to secure. And that means that as application developers, we face sort of an additional responsibility for security. And it may be driven by a number of factors. You may have compliance requirements. So a lot of times, specific to the types of applications that we see using our software a lot, there's a lot of like HIPAA compliance, companies that are dealing with medical data that really want to use encryption to protect sensitive patient information, things of that nature. Maybe corporate security requirements. There may be requirements that for applications that you write, that the data is encrypted so that you don't get corporate secrets leaking. Could just be wanting to avoid the financial liability or the reputation liability of having a breach or an attack against some of your software, because that can look really bad for a company. And then one of the interesting ones is really government threats. And I'm not putting on like a tinfoil hat, because I don't want to do that. But you're not really just worried about what's happening in the US, or you're not what's going on with our government. But in a lot of cases, there are applications that are being used in other countries under repressive regimes that you don't think about naturally, but they use these applications, and there can be really serious consequences if application data can be compromised by law enforcement in those countries. So one of the groups that we work with pretty frequently is called the Guardian Project, and if you ever get a chance to check out their site, but they do a lot of work that's very, very closely servicing those kinds of use cases. So the final part of it is really just more from a philosophical perspective. I think as application developers, we have a certain responsibility to the users of our applications to respect their privacy. So I think James in one of the earlier sessions says, like as developers, when we're dealing with these applications, we ask for a lot of data. We ask people to give us a lot of info, and we have a responsibility to treat that with respect. Treat it as we would want our own data to be treated if we were giving it to somebody else. And I think that sort of responsibility is just in general, not necessarily driven by a third party or a compliance requirement. It's just the right thing to do. So if you've got an application and you've determined that for some information on it, you really need to secure it. So some of the goals and risk mitigations at the application level, defense in depth is an important one. And that really means let's just take it and make it more difficult to mount an attack on our software by putting up multiple layers of security. So it's perfectly fine to treat the device security as the first gate. That's what the person, the attacker potentially has to get through. But then put up some other check. Does your app need to have its own security implementation to make it even more difficult to access the information that might be stored there if somebody does get access to the device? So the more layers in general that you can put between somebody who's trying to get access to information and the information itself, the better. You also want to reduce the sort of attack surface area. So you really don't want to assume for a second that the owner of the device is going to be the only person using it. So just out of curiosity, how many people in here have either a husband, a wife, a significant other, a friend that knows the PIN code or the access code to their device and can get on it? Okay. So a fair number, right? And for those of you that don't and really do keep it secret, have you ever unlocked your device to let somebody else use it, right? I mean, maybe you want to let your kids use it or something like that. I do. But, so you can't really trust that authentication to the device is actually unique authentication of the person who should be using the application. So you need to take that into consideration and really enforce that, if you do store or deal with sensitive information, that there is some other form of authentication in there. Even a minimal block to ensure that a casual user of the device is not getting into the app is better than nothing. And then you want to deal with data security itself. And this is minimizing the impact of unauthorized access, whether it's on or off the device. So if somebody really does get access either through a forensic toolkit or they get access to somebody's Dropbox files or whatever the case is, if they get access to the data, make sure that it's encrypted. Make sure that if it's lost or compromised, it's not easy to get the information out of it. And that's really the third kind of tenet for mobile security. So the strategies that your applications you want them to use here is authentication, right? That's verifying right off the bat that the user of the application knows some secret, some piece of information that uniquely identifies them to access the data. And that's even more important if your application is multi-user or your devices are multi-user. Then you've got encryption. So that's making sure that the data that your application is storing, especially locally, is unreadable unless somebody knows the secret, even if they can pull it out of a device or off a cloud service. And authenticity is ensuring that the data itself can't be tampered with. So it's very common to hear about scenarios where people are, I don't want to lose this information. I don't want it to be exposed because it's protected. But there are also a lot of risky situations where people might want to inject data into an application, either to tamper with it, display false results, cause the application to do something bad. So providing a level of authenticity to check that your information in the application has not been tampered with before use is also very important. So there's a couple of options here. So how do you do this in practice with an application? Well, one option is that from a local perspective, you don't do anything. In other words, you don't do anything locally. You do everything remotely. You're going to take and implement with the cloud service, and you never store anything on your device, on the device. You never cache. You don't pull any data down, and everything is done remotely and authenticated separately. And that is a viable option. The difficulty with that is that it can have some really significant challenges for application design in terms of usability. performance, if you're doing everything over a network connection, and then offline use. So if your app needs to have any sort of mode where it can capture information or display information while it's offline, that's not a viable option for you. So other options, you got file level encryption, right? So the devices all provide some level of crypto toolkit. So you could just say, you know, I have a file, maybe it's a SQLite database, maybe it's an XML file. I'm just gonna rip that whole thing out to an encrypted file when I'm not using it, and when I am using it, I'm gonna read the whole thing back in and decrypt it. That's viable if your data set is small. But if your data set is large, if you have any sort of significant information in the local database, it's not practical because you get an increased startup time. And then in addition to that, you often need to encrypt that data into memory if you're not going to store it on disk. And that means that you have an increased memory requirement for it as well, which is difficult on mobile. And the other challenge is that if you're doing field level encryption rather, where maybe you are only securing portions of your data in an XML file or fields in a SQLite database, is that you lose a lot of the functionality of whatever toolkits. You know, you can't really query it very well. You need to manage all that encryption yourself, so it's pretty difficult. So that's really where SQLCipher comes in. SQLCipher focuses on providing those sorts of services to an application. The idea being that it takes a standard SQLite database. So is everybody pretty familiar with SQLite? Yeah, it's pretty incredible. It's actually like probably one of the most amazing pieces of software if you really look into it. The way that everything is implemented with it is pretty much top notch. It was developed by D. Richard Hipp and still supported there. It's public domain software, so he was actually contributed the entire code base to the public domain for it as well. So SQLCipher is sort of like an extension to SQLite. You could think of it as a plugin. It's a little bit more complicated than that, but it does what I would characterize as read-write interception. So when SQLite would normally go to write some data out to disk, SQLCipher will encrypt it. And when it needs to read some data back off disk, SQLCipher will decrypt it. So it hooks in at such a low level that the application never needs to know that there's any encryption going on, other than with the exception of providing a key. The application interface is exactly the same as SQLite. So anything you can do in SQLite, full text indexes, standard table indexes, normalized table structures, subqueries, subselects, like searches, it all works just fine. So you basically get the whole feature set of SQLite, but the entire database file is encrypted. So unlike with the example that you see up here, where over there on the left, if you kind of peek inside a SQLite database, you see there's some binary data in there, but there's also a lot of easily human readable information as well if you hex dump it. So it provides that level of security that the data file itself is no longer readable. So like SQLite, it's pretty portable. So Xamarin is obviously one of the platforms that we support. In addition to that, there's Mac, Linux, Windows via ADO.NET. We also do stock iOS and stock Android. We've even got some people using it with PHP. And the other important thing is that SQLCipher is open source at the core. So there's sort of this core nucleus of code that implements all of the encryption logic, and that is open. So it's not security through obscurity. It's very easy to see exactly what's going on with it and for people to look at it and really audit that it's secure. So I'm not going to go too much into detail on a lot of this stuff, but if you have specific questions, you can definitely come and talk to me afterwards or catch me anytime really about it. But in short, we use AES 256 and CBC mode encryption, if that means anything to you. The initialization vectors are all random. We have a random per database salt. And if you're kind of familiar with brute force attacks, that'll be meaningful to you in that every database, when the key is derived via key derivation function, every database winds up with a different encryption key. So without physical possession of the database, you can't mount a brute force attack or pre-compute any of the encryption keys that would be used for SQLCipher. So that's important as well, and that's done on a per database level. We also implement a MAC. MAC is a message authentication code. It's like, you can think of it like a little tag that you can kind of attach on the end of data that, like a checksum. and a more secure checksum, but it will allow you to verify that none of the information in either the ciphertext, the encrypted data, or the initialization vector have been tampered with prior to decrypting it. So that's important for tamper resistance. The underlying implementation uses OpenSSL, which is a well-audited and very heavily used crypto toolkit. It doesn't actually use the SSL part of OpenSSL. It uses the libcrypto part of OpenSSL, which is a slightly smaller package. And because of the way that it's implemented, we have features like very fast startup regardless of the data set. So you could really throw a 2 or 3 gig database at it, and it will open in exactly the same amount of time that it would if it was opening a 4K database. So how it works, just in a little bit of detail, you've got right at the offset, when you're thinking about a SQLite database, it's not a monolithic file. It's broken up into chunks of data called pages. And each one of those pages includes basically an index subset of the data at that location. So SQLite, first off, normally it has a kind of a magic string at the front of it. I don't know if you've ever opened it up in VI or Hexdump or anything like that, but it usually says like SQLite version 3 in text. So we take that part over, and that 16 bytes of data becomes a random database salt for that particular database. And then every subsequent piece of data in a page is encrypted. That's the page data. And then at the end of the page, there's some reserved areas, and that's where we stick the initialization vector for the cipher, and we also put in the MAC code for that. So let's talk a little bit specifically about Xamarin then. So within the context of the Xamarin Component Store, SQLCipher provides essentially a drop-in replacement on iOS and Android for a lot of for 2 of the very commonly used SQLite interfaces. So you've probably seen at least at some point Monodata SQLite, which is the ADO.NET provider. And then especially during this conference, there's been a lot of talk about SQLite Net. So both of those interfaces are provided and essentially embedded with the SQLCipher component so that you can use exactly the same code that you would on an unencrypted database versus an encrypted database with only a few minor lines of code change. The installation from the component store, you've kind of seen, I'm sure, in the demos that have been on this week, is like crazy easy. And more importantly, if you're enterprise licensees of the Xamarin tools, this is entirely free for you. So even though the lower level licensees, there's a charge for it, if you're on the enterprise side, you can just download this and use it immediately, drop it into your applications at no cost. If you're not on the enterprise side, there's also a free trial for it available. So installation in your project is really as easy as kind of right-clicking and doing get components. You just search for SQLCipher, and when you find it, add it to your project. If you're doing a trial version, it's a little bit more involved because you actually download a zip file that has the assemblies in it, but that's okay. It's like one extra step, and I've got some resources at the end of the talk that can help a little bit with that. So we've done a tremendous amount of work during the component store packaging step to kind of rework the entire way that we built SQLCipher. So we actually provided it for MonoTouch and Mono for Android prior to the component store, and then put it into the component store when that was released with Xamarin 2. Right now, even though SQLCipher does depend on native components, so there's like a static library on iOS, and there's a shared library on Android, all of that is handled automatically via the component store. So it automatically sets up your project to properly link in the static library or link the shared library and then distribute it with your APK on Android. So there's really no work that you have to do other than just adding it to the project. Once you get it in there, if you're used to the ADO.NET style, you can use Monodata SQLCipher. And that's really, this shows you kind of an example with the bolded sections. I don't know how easy it is to see there, but you're really just changing 2 lines. The first one is changing using Monodata SQLite to Monodata SQLCipher. And then you've got to add an additional call once you're getting the SQLite connection to pass in the secret data. That would be the password or the secret key information that you want to use for that. So otherwise, it's identical. So your porting steps are negligible at this point. And very recently, we just added support for SQLite-Net. This was actually in sort of response to some requests and discussions with Xamarin, since it's really the recommended way of doing it. And this is Frank Kruger put this library together as like a light wrapper for SQLite that also provides ORM functionality. So you can also use this. So if your code is that which has been developed over the course of time with SQLite-Net, you can easily port it. If you're using ADO.NET code, or even if you have ADO.NET code that you're using from like an enterprise project, from like SQL Server, it's pretty straightforward to port it over for local use as well. So the end result, after you make those changes and build your application and run it, is that the data that you're storing locally is indistinguishable from random data. So it just looks like a complete, one huge random data file. So one thing that comes up quite frequently is how does it perform? So the focus on usability for mobile applications is important. You don't want to have a lot of delays in your app. And we've done a lot of work to really minimize the overhead of encryption with the design here. So we generally estimate that for a typical application, you're going to see somewhere between a 5 to a 35% impact for using SQLCipher versus standard SQLite. That's based on some kind of general parameters around how most applications work. So in some cases, it's possible for it to be even better. In some cases, it's definitely possible for it to be worse. But in most cases, you're going to fall somewhere in that range, which is generally very acceptable because SQLite, as it is, without encryption, is incredibly fast. So when you're even layering on the additional overhead for encryption, you're still talking about a very speedy interface. That said, within the context of SQLCipher, the design of your database is important, and the way that you use it in code is a little bit important. So there's some do's and don'ts that you need to be aware of. For example, it's much better if your data store, your data model is at least reasonably well normalized. If you have a lot of duplication in your application database, like everything's all in one table, and you have a lot of redundant information, what happens is that when you're querying that, or even worse, updating it, you end up having to do a lot of sequential writes to update any information. Using indexes is very important. So if you're looking up things on an index with SQLCipher, you can sometimes get it down, especially if it's like one row, you can sometimes nudge it down to like a 1% impact to get the data out, especially if it's a small amount. However, if you're not using indexes on anything, then the database essentially has to scan through your entire table. And if you think about the way that it's broken up in pages there, you lose all the benefits of the framework for doing that. It has to read the first page and then, oh, that row isn't there, and then read the second page, not there either, and the third page, ad infinitum. So it's really important that you kind of optimize your database with indexes. That's usually, even if it doesn't use indexes right now, that's usually like a 1 or 2 hour exercise to go through and make sure that you have it pretty well indexed. It's not really a lot of work. You do want to be using transactions as well. So if you're not using transactions and you're doing a lot of sequential updates or inserts in SQLite, even if you're not using SQLCipher, you're losing a huge performance benefit. The differences, and you can kind of even see here with this table, the differences between transaction versus non-transaction on insert is crazy. So you always want to make sure you're using transactions there. The things that you don't want to do would be kind of really frequent non-index queries and any sort of massive updates where you're just going to go through and update everything in a file, because that takes a long time. It's everything that SQLite has to do plus everything that we have to do with the encryption overhead in addition. And the other thing you don't want to do definitely is open new connections for every operation. So that's unfortunately a pattern which we sometimes see, because in SQLite it's very cheap to open up a connection. It's just really a file open. So sometimes people kind of write code that will open the file every time they want to do an op on it. With SQLCipher, that's bad, because the first operation, whenever you touch the database, it's doing the key derivation step. So it's taking the password that you put in, combining it with the salt from the database, And in this case, we do PBKDF2, which is an iteration of several thousand SHA hashes to derive the ultimate encryption key. And that's to help address brute force attacks. So if you open a new connection every time, then every time you're going to be doing key derivation, and it can really slow things down. So there's also a couple of things that are sort of advanced features with SQLCipher. These you get, you don't have to use if you don't want to. We provide an ability to rekey a database, so if you want to change the encryption key on it. We do allow you to change out the cipher that you're using, so AES 256 CBC is the default. If you have a very specific need for some reason, you could change that to another cipher and mode that is supported by OpenSSL, and we allow you to do that, although we generally don't recommend it. If you have specific needs around key derivation, you can increase the number of iterations that are run up to whatever number you want. So you can make it as quick or as slow to derive the encryption key as you need for your application-specific requirements. And then we have, from a performance perspective, if you're dealing with large data sets, we give you the ability to adjust the page size. So with SQLite, when we were dealing with those boxes up on that earlier slide, by default, those are 1,024 bytes. You can increase that if you're dealing with larger data sets. It can be more efficient to use a larger page size. And finally, with the kind of tweaking of the encryption algorithms, we do allow you to disable HMAC. That can give you a slight amount of performance improvement, but it's at the loss of the tamper resistance. So you really can't authenticate the data in the database file before you decrypt it. So that's kind of a big limitation, so we generally don't recommend that either. In a specific case of application conversion, if you have a database that's now unencrypted and you want to encrypt it to a new database, we provide a function called SQLCipher export. And basically what you can do is take your standard database, attach an encrypted database, and move all the data, tables, structures, virtual tables, everything over from one to the other. And if you want to do the reverse, so take an encrypted database and move it back to a standard SQLite database, you can do that too. So those are some of the kind of advanced tricks there. And then just to kind of cover a couple of the frequently asked questions, and if there are any others after this, we can definitely discuss them. The biggest one is always, where does the key come from? So I'm sure somebody would have asked that eventually. And I think it came up in one of the other sessions. That's a big challenge. Key management in any sort of security system, encryption system, is a really important topic. In our recommendation, at least part of the key always needs to come from the user. So if you're thinking about just kind of statically compiling in an encryption key and letting it run and distributing your app, it's really not a good thing to do, because somebody will open up the app package and look in it and find out what the key is, and then they can get all the data. So part of it, at least you want to have come from the user. You can also combine other information. So if you have a remote service that a person is signing into, or you have some device-specific data that you initialize with your application, there's definitely benefits to mixing some of that into the key material as well. So you're not limited to just using a password or just using an embedded string or using something that comes from a remote service. You can mix and match to suit your application's particular needs for it. Lost credentials, not much you can do there. If you forget the password or you forget the encryption key, you're cooked. Existing databases, migrating them, I think we actually talked about that a little with attach and SQLCipher export. We often get questions about compression, so every once in a while, on the mailing list, it is an open source project, we have a mailing list for it as well. Somebody will say, I've got this big database with all this information that we want to kind of keep secure, and we've been distributing it as part of our APK in the assets folder, and it's like 60 or 70 megs, but it's all like redundant data, so it zips down and it's very, very compressed, and then they switch over to using SQLCipher and they're like, now my APK is like 60 or 70 megs, it's not usable. That's really not much we can do about that. By design, the database is indistinguishable from random data and just by definition cannot be compressed. So you need to be cognizant of that when you're doing data transfers of SQLCipher databases, or if you're distributing SQLCipher databases as part of your application packages, that's something to be aware of. Portability is really good. In addition to Xamarin, you can get SQLCipher for a number of other platforms. You can run it on Linux. You can run it on Windows. You can even take a database file that you have from an iOS device, and you can put it on a Linux box with a big endian, like a MIPS architecture, and it'll open up there too. So portability of the database files and portability of the code is pretty important to us, and we're trying to get it out there as far as we possibly can. So if you have requirements for taking your mobile device databases, for example, preparing some data with them and then sharing them off to another service, or allowing some sort of sharing between desktop applications is not uncommon. Synchronization, those are all really good use cases because you get great data portability with it. And then the final thing I wanted to mention, just because it's really important for people who are distributing apps commercially or exporting them, is you do have, if you're embedding encryption in your applications, you have certain responsibilities under the export administration regulations. So the Department of Commerce and Bureau of Industry and Security have a set of regulations about who you can export your encryption code to. And part of it is like don't distribute to a certain set of exported restricted countries, restricted organizations. There's a whole exclusion list that you can't give out to. But the other part of it is that you actually need to register your application. You need to register yourself as a company, number one, with them. You need to get an ERN, which is an encryption registration number. And then you need to do like yearly audits where you sort of self-classify your software and submit it to them so they're aware of it and the fact that you're exporting it. If you don't do that, you can get in a lot of trouble and it's bad. So if you decide to use SQLCipher or any other encryption that you roll your own, definitely take care of that. One of the common misconceptions with it is that if the vendor who's providing you the security toolkit already has their own ERN or is already registered, that you're covered on it, and you're not. You're not covered under that. You're technically re-exporting the encryption as part of your application, so you are responsible for doing all that work yourself as well. So a couple of resources here. The first one there is just our link to the component store, and that'll be available offline. We've also got a little sample app, which is called SQLCipher app Xamarin, up on GitHub. That was something that we did for the little mini hacks here. And if you're interested in seeing what it actually takes to convert a standard application to an encrypted application, it's a great resource to do it. When you pull the code off GitHub, it's not using the encryption, the SQLCipher encryption, and then it has a walkthrough in the README that just walks you exactly through what steps you need to take to switch it over. Grab a trial version from the store, embed it in the application, and move along on your way. From a performance perspective, there was that screenshot that we had of the little table with some of the performance stats. That's actually an application that we've pushed out to GitHub as well. It's not intended by any means to be an exhaustive performance test. We have some other standard benchmarks that we run on SQLCipher that are not on device. But the nice thing about this is if you have questions about like how would this query, perform in my particular, my particular application, you could grab that, pull it down, set up in the test runner what your queries look like, and kind of get a rough comparison of what the impact would be. It's not really good to do exact numeric comparisons. The difference is the importance is the difference. So what that app does is it takes each query that you write and it executes it once on a non-encrypted database and then once on an encrypted database and compares the timing between the two and then gives you what the difference is. So you can see kind of generally where the impact would be. The link down there to the doc.gov, distribution, go check that site out. It's got all the rules that you need to do before you can actually start handing apps out to users. SQLCipher.net is our project, main project site. So you can go out there, check out any support information, look a little bit at the API, the implementation details, links out to the mailing list, support options, and the whole nine. So that's out there. And the final link is to our site, Zetetic. So if you have any other needs, we provide support services for SQLCipher, consultation on implementation, secure mobile audits, things of that nature. If you have any questions about it, feel free to reach out to us there. So at this point, I think we have maybe like 5 minutes left. If there are any questions, I'd be happy to answer them.
You mentioned that SQLCipher works with SQLI.net.
Mm-hmm.
Are you guys going to be updating whenever SQLI.net brings out a new release or something like that?
Yeah, that's our intent. So we actually track in the same way that SQLCipher is an extension to SQLite. We track upstream releases of the projects that sort of feed in to SQLCipher and that we extend, and we do keep them up to date on there. It might not be like immediately like the day after a new release comes out, but anytime there are new features, major updates, and things of that nature, we do upgrade the library support for them.
Okay, and one more question, sorry. You mentioned also that if you're going to use something like SQLCipher, you are to register to the government. So what if I am from a different country and my application is being distributed in this case as well?
You know, that's kind of a that's a question I'm going to have to pass on. I'm not really sure. I would say that from Apple's perspective, even if you are outside of the US, you still need to do the registration. So the DOC will not prevent you from registering for an ERN, even if you're in a different country. And Apple will still require that even if you are distributing from a different country, that if they're going to be selling the app outside of the United States and Canada, that you have to provide them with the ERN evidence. So it's required for Apple. On Android side, I'm not sure, and I really don't know the legalities of that either. It might be worth the BIS on that one link I gave you. They have export counselors. I've spent hours on the phone with their export counselors. They're pretty good, and they essentially can walk you through if you have specific questions about, you know, where does your app fit or what it's doing, how should it be classified, or what your requirements are. They can answer those. So it might be worth giving a call to them. Yeah, there is actually also one other thing in terms of export. You can't export to France either unless you do a separate. There's a separate registration process in France too. So that's another one where you have to worry about it.
When you're writing to it, how often do you save it to disk, or is it automatically saved to disk? Like, you know, say the app would crash and when would you recommend that the data gets saved?
Yep, that's a great question. So just to repeat the question, it's how often does SQLCipher write to disk, and if you're writing to making some updates to the database and your application crashes, does the user lose any data or anything like that? So the answer to that question is that SQLCipher is really always writing to disk when you're making updates, but the way that it's handled is that it's getting written out to a separate journal file. So if the application crashes in the middle of an update, it's really going to be recoverable back to the state before that transaction started. So if you're using a transaction, the moment you start the transaction, you're going to be in a consistent state. Every write that occurs after that is going into a separate file. And then at the point where you commit the transaction, it gets merged back in. That's what the default journal mode. There's also an alternate journal mode, which we could talk about offline, called WAL, which is write-ahead log mode, which has some good benefits. It works a little bit differently. But the net of it is that it's really constantly writing out, but it only gets committed into the database when you commit the transaction. Now, if you're not using transactions, that's every update. So if you write an update or an insert and you don't wrap it, then that is a transaction. And that's why, you know, incidentally, if you're not using transactions but you're doing multiple inserts or updates, it's so slow. It's like horribly slow. You know, you might see that you can get, I don't know, 20 or 30 inserts, you know, a second in, whereas you could get 15,000 inserts a second in with a transaction because of that, because each transaction flushes.
Is there a way, if you have the original credentials, to update new, like a new password to the database?
Yes. That's actually, there's a pragma for that called rekey, and rekey does exactly that. So you have to authenticate once with the key that you're currently using, and then you call rekey with a new key, and that goes through and re-encrypts the entire database with the new key. So that's built in. The one downside to that is that it's a long-running operation if you have a large database. But not to go too far into roadmap with SQLCipher, but one of the things that we're really planning to do in one of the upcoming releases is provide an option for a separate key file. The key file would be sort of separately encrypted and stand aside on the side of the database. And that would allow you to essentially rekey just by re-encrypting the key file, and then the key file contents would actually be the encryption key for the database. There's a couple other benefits to that too, because it gives us a little bit of extra flexibility about how we store information about the key and the cipher setups. And the other nice thing about that would be that it would facilitate situations where you want to distribute the database, but you don't have to distribute the key file. So it would actually make it really, really much more difficult to attack in a case where even a database is compromised if they don't also have the key file.
Could you put some scope around your definition of large for the rekey?
Well, I might want to run a test on it. I mean, I would say that I've like rekeying like a 1 meg database on a reasonably recent iOS device, maybe 5 or 10 seconds. You know, it's not horrible, but it does essentially have to rewrite every page in the database. So it's definitely something that you would want to do, you know, asynchronously. You know, you wouldn't want to be, you know, hanging up your main UI thread to do that kind of stuff.
Hey, just 2 quick questions.
Sure.
So that roadmap, that thing that you were talking about, do you have customers right now that are just encrypting their own key with their own library, you know, and then using that in code? Yeah,
we do. And there is actually a facility. If you pass in to the SQLite, in the examples that you saw up above there, where you were passing in the key, there's a certain notation for essentially what SQLite calls blob syntax, but it's basically binary data. You can actually pass in a hex key. It's got to be a little bit specially formatted, but I could get you the information if you want, and it will use that key directly. So if you want to do your own key management externally to SQLCipher that is not using the standard and default key derivation, you can do that as well. And there are people that are doing that today.
Cool. And then question 2, do you have customers that are storing PCI data?
I don't know of any firsthand, but I would be very surprised if there are not. So I don't have a great visibility into everything that all of our customers are doing, partially because some of them are either doing it off the open source kit, or if they're purchasing the software, they're really under no obligation to tell us what they're doing. But I can definitely say that we have a number of customers that are in the financial sector that I would strongly suspect are doing PCI data. Yeah. Okay, I think we're done with now. So thank you very much. I really appreciate you coming out.